Good day and welcome to our class on real analysis. Today, we'll be talking about supremum and infimum. We'll be talking about supremum and infimum. Supremum is also called the least upper bound. Supremum is also called the least upper bound, which some people refer to as LUB, while the infimum is the greatest lower bound, which you can also refer to as what? GLB. How then can we define supremum and infimum? Before we go to the definition of supremum and infimum in terms of the sequence, let's look at an example. Consider sequence S defined as such. The greatest number in this set is 10, while the least number is 5. But 10 and every other number greater than it is what we refer to as the upper bound. So when we are talking about the upper bounds, we are talking about what? The greatest number and every other number greater than that greatest number. 10, 11, 12, 13, 14, and the likes. When we are talking about the lower bound, we are talking about the least number and every other number that is lower than it. So we have the least number to be 5, 4, 3, 2, 1, and the likes. When we have the greatest number to be in the set and the set or the sequence is closed, then we call that upper bound the maximum of the set of the sequence. So the maximum for this is 10, and then the minimum will be what? The least number in the set, and that is 5. The least number is 5. Now, in terms of this now, what will be our least upper bound? The least of the upper bounds is what? 10. And the greatest lower bound is what? Is 5. Let's express what I'm saying on the number line. Assuming this is our number line, then we have the set of real numbers, and that is 5, 6, 7, 8, 9, 10, 11, 12, 13, 4, 3, 2, and the likes. If I have here a closed interval, such that what? 5 is less than or equal to x, less than or equal to 10. That is what I have in that interval. So my 10 here is an upper bound, and every other number that is bigger than 10. While my 5 here is a lower bound, and every other number that is lower than 5. So 4 is a lower bound, 3 is a lower bound, 2 is a lower bound, just as 10, 11, 12, 13 are upper bounds. Now, which one is the least upper bound, which we call the supremum? The least upper bound is what? 10. While the greatest lower bound is what? 5. In line with this now, let's try to bring out definitions for our supremum, our upper bounds, lower bounds, before we now talk about the supremum and the infimum. Let's define upper bound. Given P contained in the set of real number, so if we have a sequence P as defined as such, contained in the set of real number, such that U is also an element of R, then U is an upper bound of P u will be an upper bound of p if x is less than or equal to u for all x belonging to p. That's why I said every other element in the sequence or in the set must be less than our upper bound, must be less than or equal to our upper bound. Now let's talk about lower bound. Lower bound. Given P contained in set of row number and L belonging to that set, then L is a lower bound of P if X is greater than or equal to L for all X belonging to P. Every X in P must be greater than or equal to L, which we call the what? The lower bound. Let's now try to define maximum and minimum. In line with upper bound and lower bound, we want to talk about the maximum. We say, given P a subset of the set of real numbers and U belonging to the set R, such that U is an upper bound of P, such that U is an upper bound of P. And so if U is an upper bound of P, then what happens? P is a maximum or a maximal element in P if U belongs to P. Again, we'll talk about the minimum. Given P subset of the set of real numbers and L belonging to the set of real numbers, where L is a lower bound of P. L is a lower bound. That means every other element in P is greater than or equal to L, as we have defined here. So if L is a lower bound, then L is a minimum or a minimal element of P if L is contained in P. Remember, we are still going towards the supremum and the infimum of a sequence. The supremum and what? The infimum of a sequence. Now, you remember that I said that the greatest upper bound, the least upper bound rather, is what we call what? The supremum. And the greatest lower bound is what we call what? The infimum. Let's now bring out a definition for the supremum and what? And the infimum. Given P subset of R and S belonging to R, then S is called the supremum of P. S is called the supremum of P, or the least upper bound of P if 1, X is less than or equal to S for all X contained in P. That is, S is an upper bound. S is an upper bound of P. S is an upper bound of P. Yes. If X is less than or equal to U for all X contained in P. Same thing happens here. So the first condition must be that X is an upper bound. And then 2, for all epsilon greater than 0, there exists a Y in P such that S minus epsilon is less than or equal to Y. And if S minus epsilon is less than or equal to Y, then it does what? It implies that S minus epsilon is not an upper bound. And so, assuming our epsilon is 0, then it means that our S is less than or equal to Y. Therefore, the supremum of P which we write as sup p is equal to what? Is equal to S. The supremum of P, which we write as that, is S. In the same way, let's try to define our infimum. Following the same line, given P contained in R, I'll use I for infimum now. I belonging to the set of real numbers. Then I is called the infimum. I is called the infimum of P, or the greatest lower bound of P if one. The first condition is that it is a lower bound. And if it is a lower bound, X is greater than or equal to I for all X contained in P. For all X contained in P. That is, I is a lower bound of P. More than that now, for all epsilon greater than 0, says for all epsilon greater than 0, there exists a Z contained in P such that I plus epsilon is greater than or equal to Z. And this implies that what? I plus epsilon is not a lower bound. But if our epsilon is 0, as we have assumed, then again, our I will be greater than or equals to Z. Therefore, the infimum of P, which we denote as inf P, is equal to I. Let's take examples and try to bring out the infimum and the sup. Is given the sequence G defined on the closed interval 1 to 3, and Q defined with the given elements there, 2, 1, 1 over 2, 1 over 4, 1 over 8, and so on. We are told to find the upper bound, the lower bound, the least upper bound, and the greatest lower bound. Now, for sequence G, defined on the interval 1, 3, it means we have what? 1, 2, 3 in that interval. So what will be our upper bounds? Our upper bounds will include rather 3, 4, 5, 6, and so on. Our lower bounds will include what? 1, 0, minus 1, minus 2, minus 3, and so on. Our least upper bound, which we call the supremum, will be what? 3. It says S less than or equal to X, X less than or equal to S, and then what? S is less than or equal to Y. And so our supremum is what? 3. That is the least of all the upper bounds that we have mentioned. And the infimum is 1. That's the greatest of all the lower bounds that we have mentioned. Let's look at the next one. Our sequence Q, defined as what? 2, 1, 1 over 2, 1 over 4, 1 over 8, and so on. This is an infinite sequence. The biggest element here is the 2. However, when we look at the trend of this sequence, we see that what? It is tending towards 0. This is 0.5, this is 0.25, this is 0.125. So it is doing what? Tending towards 0. So we know that our lower bound will start from where? 0. So what will be the upper bounds? Our upper bounds are what? 2, 3, 4, 5, 6, and the likes. And our lower bounds, we begin from where? 0, minus 1, minus 2, minus 3, and so on. So what will be the supremum, which is the least upper bound? The supremum is 2. And what's our infimum, which is the greatest lower bound? Our infimum is 0. We take another example. Let us consider the sequence J, which is the reciprocal of natural numbers. where n is from 1 to infinity. What are the elements of this set, of the sequence? We have 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. It is an infinite set also. But even also, if we look at it, we see that it is doing what? It is tending towards 0. And so if it is tending towards 0, we know that we do what? We have an upper bound and we have lower bounds. What is the highest number in the sequence? 1. So every other thing that is greater than 1, we have 1, 2, 3, 4, 5, and so on. Those are the upper bounds. The lower bound, what? We can see that it is tending towards 0. So our lower bound begins from 0 and it moves on to -1, -2, and the likes. Therefore, our supremum, which is the greatest, the least upper bound rather, the least upper bound is 1, and the infimum, which is the greatest lower bound, is 0. We look at another one. Consider the sequence W defined as what? 3n plus 1 over n, where n moves from 1 to infinity. We want to find the upper bounds, the lower bounds, the supremum, and what? And the infimum. If we look at this sequence, 3n plus 1 over n, I can break this down, and it gives me 3n over n plus 1 over n, and this is what? 3 plus 1 over n. So what will be the terms of the sequence? I have 4. I have, that's 3 plus 1, 4. The next one is 3 plus 1 over 2. 3 plus 1 over 2. The next is what? 3 plus 1 over 3. The next is what? 3 plus 1 over 4. The next is what? 3 plus 1 over 5. And it continues like that. But if I look at it carefully, we can see that this is doing what? It is tending towards 3. It is tending towards 3. So what are our upper bounds, our lower bounds, our supremum, and our infimum? The upper bounds would begin from 4, because that's the greatest number in the sequence. 4, 5, 6, 7, and so on. Our lower bounds we begin from where? 3. That's the least number where this sequence is tending to. So we have 3, 2, 1, 0, and the likes. Our supremum, the least upper bound, is what? 4. The infimum, the greatest lower bound, is what? 3. Try your hands on the following. Bring out the upper bound, the lower bound, the supremum, and the infimum for the sequence. Thank you for watching thus far. If you have benefited anything from the video, or if you think the video has helped you to understand more about supremum and infimum, give it a thumbs up, like it, and share with your friends and colleagues. Thank you very much. God bless you. I see you in the next video.